Hello to part 3. In this video I will show you how to create your custom ISaveData in case that the S-type data you can use aren't enough for your project. So, all you need to do is simply create an empty script, name it like you want, you need for your class. In this case we call it inventory and open the script. Since we want to make the class persistable, we have to using Kobeltstuff.common to be able to implement an ISaveData interface. So we are implementing it. We get all three methods that are needed for the persistent part. But first we have to create fields that we can persist, like on public int. We can use everything that is representable in binary, like int max slots, like public vector 2 grid size, or public public string display name. So then we want to use, for example, a dictionary. We can even do it private. No need to differentiate between public and private for the save action. We just have to select them in the generator you see in a moment. But for now we want to have private as dictionary, and as key we can have all primitives like a string, and we want to have as value an ISaveData only, so we use SInt, for example, and call this data, and don't forget to do a new on that, since ISaveData has a strict not null policy. So that's all we need for now to implement our persistent methods. Now we want to go back into the editor and call the generate save data class from the menu, and this will open us our code generator for an ISaveData. And all we have to do here is typing in our class name and load the type. For best practice, I recommend to just copy the qualify assembly name and just put it on top, since if you want to change the name or the assembly or anything in the qualified name, you have to have the old one to migrate it to the new one. So just do it here so you never lose the old qualified name, for example, and then go back to the generator, and the generator tells us all of our fields in our class. So we see we have max slot, grid size, display name, and data, and we want to persist all of that, and it's fine. Or maybe display name we don't want to persist. This can come over over the mono behavior later on. And now we persist 3 fields, 2 publics and 1 private field, and just click off Generate Code. Note, it tells we are on version 1. It scans for this version field and auto-increment it, but more to it later. So we start with a copy part, just copy all, overwrite this copy, and we have a complete block. We have an empty constructor and our copy method and a copy constructor. So we have everything we need to have a snapshot and to differentiate between runtime and save data, and for first of all thread safety at this point. So let's get further with the next step, the writer. Just copy it and overwrite the writer part, and you see here the version comes with it. It's important for migration. If you are refactoring anything here, you have to change it if your class is already live in a build and used by users. So, and you have your write bytes method, version, and the data gets written. No need to worry. This is easy as it gets. And now we copy our switch methods and copy it here. That takes over the read bytes method, which reads the file version and decides on that file version which reader, since we are in version 1, we have only one reader, is get called. So, and so we are adding our read bytes version 1. You see, and this is all there is to it, and now is our inventory saveable without problems. And if we are refactoring, we would do just lot type after we are saving it, and a lot type, generate the code, and you see it knows we now have version 2, and in version 2 we just would get the switch part and insert version 2 reader, and therefore we can migrate our data at any moment, at any time in our project. This is all there is to a custom ISaveData. And how to use the ISaveData and how to generate a mono behavior, implement ISaveHandler to talk with the save system, we see in the next part. So, I hope I will see you there.